So yes.
It's the first time that we take a little bit look at the Inspire.
Yes.
So I'm very new to this subject. I'm very interested because we are looking as well into a project for landscape data risk assessment, which will probably be in collaboration.
We do. So we have
exactly. So that is why I'm looking now the first time these all Inspire geographical sets.
So if you need anything,
Exactly. So
maybe Right, dear colleagues, good morning. It's very good to have you here. Our session is entitled Enabling Access to Spatio-Temporal Observation Data through the use of the Sensor Observation Service and Observations and Measurements. In terms of structure, what you're going to see is subdivided into 4 subsections. What we're going to try to do first is give you a very brief overview of what a sensor observation service and observations and measurements are, and then relate a little bit more on the situation with ONM and SOS within the context of a spatial data infrastructure, Inspire in particular. Then we're going to briefly look at the available technical guidance documentation, as well as reference implementation that we have got. This is part number 1 of the workshop. Then we're going to probably the most interesting part would be dedicated to different use cases, different examples from the practice where a sensor observation service, where ONM are effectively used to serve to broadcast spatio-temporal observation data in the majority of cases coming from sensors. So what we're going to hear are use cases from the field of air quality. There's a lot of examples from the marine domain, in the field of geology, as well as some citizen science examples. In part 3 of the workshop, we would like to touch upon some of the pending issues, because there are, as you will see, there are very diverse use cases. So there is, of course, no one solution to fit all of them. We want to discuss briefly what is the way ahead, what are the challenges. And then we will give the floor to you. So we have allocated 15 minutes so that we have a question and answer session. Still, if you have some questions that you would like to ask before that, please, we encourage you to do that. Let's make the most out of our workshop now and do it as interactive as possible. So, with this having been said, part 1, the introduction. So what is the context? Why are we having this workshop now? Think of what has happened during the past 10 years in the geospatial domain. Geospatial information, if we look 10 years ago, was very difficult to discover. There were no web services exposing it. It was distributed through files, absolutely different structures, very difficult to access and to use. Well, now the situation is completely different, right? We have WMS, WFS, web coverage service, and so on that are exposing this data. Users know what tools to use so that they download, they interact with those data sets. Same thing we expect is going to happen with the spatio-temporal, because WFS, WMS, WCS have got more to do with features, so presenting a more, let's say, static perspective on the world, whereas with spatio-temporal, we add another dimension of complexity, so we include the time. Why do we include the time? Well, there are objective reasons for that. You know that the connected devices to the internet are growing so rapidly that actually they are projected to reach 50 billion by the year 2020. So Internet of Things, phenomena like big data, are fundamentally changing the way in which we are sensing, we're collecting the data about our environment. Some call it a revolution. That is similar to what happened with earth sciences in the 70s with the deployment of satellites. In any case, there is, in Inspire, this is well considered, because as we all know, it's a framework directive that is focusing on the spatial, which is also encoded in the name. But environmental monitoring facilities, they include observations and measurements, so this is well considered by design to have a spatio-temporal dimension. In terms of data teams, it's, as already said, quite diverse, but this is just a few examples of some of the 34 inspired data teams that already consider inclusion of observation data. There are some possible future extensions and maybe combined use data that extended schemas and so on. SOS and as a standard and O&M, they fall, they are created by the Open Geospatial Consortium, so they fall within the umbrella of, they're part of a suite of standards entitled Sensor Web Enablement, and the Sensor Web Enablement, the suite actually provides everything needed for one to be able to encode the observation data, to serve it through the means of the SOS. There is a markup language that is called SensorML for describing the actual measurement process, for describing the individual sensor platforms that are being deployed. So all of those standards that I mentioned are meant to work together so that they satisfy a heterogeneous number of use cases. So now I give the floor to Kathy to dive a little bit more into the details, starting with the encoding of the data. So O&M, Kathy, the floor is yours.
Okay, so starting with O&M, what is an observation really? And the most relevant parts of an observation are what was measured. In O&M speak, this is the observed property. You need to know where was it measured, so your feature of interest, what am I measuring on? What's then often forgotten is also the how was it measured. This is just sort of implicit, of course I measure it this way, but if you want to analyze the data, this is very relevant information. If you don't know this, you can basically throw the data away. When it was measured, and also you need some data quality information. And of course the result of the observation, but that's the part everybody sees as obvious. The other parts up top are very relevant and often forgotten. And for this purpose, you've got the O&M standard. This is an ISO standard 19156, has been included in all the Inspire work. And there you nicely have this information all collected in one feature type. So if we look now at the various points I had, we've got what was measured, the observed property. That's down here for anybody who then looks at this again at some point in the documentation. Where it was measured, if we talk loud, feature of interest is, I think this thing as far as I can read it. Then you've got the procedure, how it was measured, is the box at the top. These are all three external features. And then you've got your phenomenon time and result time. So it's all nicely packed in this data type. And what do we have relevant here? Okay, here we've got the parts which are really external parts in bold, and the bold parts are already provided within the environmental monitoring facility part. So these three external features I've now shown, which the observation references to, you find on the other side. If you describe a facility, those parts are also there because you're describing the place where it was measured, you're describing the facility which has this measurement device, and you're describing what can the facility measure. So this is the basic core of the observation stuff. Now, any quick questions on that, or is this? Think about it further. You have questions at the end. We will sort through that. Second point, SOS in a nutshell. What is SOS? It's an OGC standard currently at version 2. It's good for when you really have the type of data I was describing earlier with the O&M observation. It's the sanest way of providing that. Theoretically, you could provide it via a feature service. It is an OGC feature, but you lose a lot. And that's what the SOS is for. It's part of this whole sensor web enablement suite. And the core operations, I mean, it's got to get capabilities just like the feature service, map service, all of the services. But it has really specially tailored operations for getting this type of data. So you've got the get observation call, which you can use to specify what observation you want based on this observation metadata. Nice things, you can also put in a temporal subfilter and say exactly this time slice is what you want. You've got a dedicated describe sensor call, which gives you the measurement methodology. You've got the get observation we had. You also have the get observation by ID is a way of getting a specific observation. And what we don't have in this overview is there is also a get feature of interest. So you can also query the spatial feature, which you would normally be getting from the feature service. Same thing comes up here to make sure that the data provided is all one consistent set. Further bits within the sensor web enablement suite, we also have the sensor planning service. There you could actually trigger a sensor and task it with certain operations, say, okay, now you're relevant, start measuring. The sensor event service is if something happens, the service can also really send out active events, and that works in cooperation with the web notification service to get those events then into your application or whatever device you want it. Ziva? I think it's Ziva.
Okay. When was that? Back in 2011, we produced the first round of guidance document, mainly around the, is that working? Yeah, the O&M and SWI guideline documents. Basically, this is something that was generated out of different themes in Inspire that suddenly realized they needed a common space to expose best practices regarding O&M and SWI. And okay, it was the first guidance document, and then there was nothing regarding how to download observation. So recently, and it started end of 2014, but more important work overlapping 2015 and this year is refining this D2.9 document and also including a new technical guidance so that the sensor observation service can be considered as an Inspire download service. And also, we of course work so that both documents are linked. Current status as of today, the consultation for member state, because it was the two documents were pushed to the MICT for member state comment and feedback. There was no blocker. There was, what did you say, Alex? 17? 16? Okay. 17 countries replying, and most of them were just okay, and some of them also okay, but it taking into account several comments, mainly from Denmark, Netherlands, France, and Sweden. So I'll just guide you through these two documents, quick overview. What is important as well is to keep in mind that both those exercises have been conducted in parallel, so that and reinforce the link between two documents. And it is not only a pure theoretical work. It's based on the expertise we've all gained, either via the OGC spec or the implementation in our respective structures. So we have service up and running according to what's written, or that's what's reality. So D2.9, what we did is we restricted the document to differentiate what was explanatory text of O&M about O&M and SWI from recommendation guidance. Because the previous version was both kind of exercise in the same sentences, so it was really hard for newcomers to discover what is O&M about, what source is about, and what they should or should do. So we moved to, I think, a structure that is that is compliant to the OGC modular specification structure. So recommendation and requirement are in a core part, they are uniquely identified, and so to improve readability, we also have normative and informative annexes. So there are three main parts in that document. There is a decision tree leading to O&M design pattern. We have an observation and measurement Inspire profile, and we also have a chapter dedicated to the service layer. So this is the overview of the decision tree. The idea of that decision tree is to have a one-stop shop for the newcomers, I would say, in providing observation data to entering here, and each node of that tree you could kind of answer a dedicated question, and the purpose is to guide the person, the implementer, down to the type of specialized observation they have to actually deploy within their data infrastructure. So, for example, I will take one example from Belgium, where I work for groundwater observations. We really care about the result, but also a lot of what Kari presented as what we could call metadata on the result. What was the procedure, what type of sensor, quality information, blah, blah. So we're more kind of observation-centric stuff. Our piezometers are point-based. They are deployed on a fixed location on the ground. And actually, they acquire multiple times the same parameters. They observe the same property over time. We have series that can last like 40 years. So basically, we definitely fall down into the point-time series observation, specialized observation. That's one way of reusing that decision tree. And yes, the next slide is about that specialized observation. So that's the way we structured that chapter in document, so that you get an overview sketch allowing people to get a quick view of how to map domain terminology down to the core O&M structure, explanatory text, and down the requirement recommendation with its unique, I would say, URI, even if it's not resolving here. And when you are in that type of context, you should use this type of specialized observation. And all the details of each specialized observation is down into an annex that is linked to the feature catalog of Inspire specialized observations. Then the second part is the core observation profile. So we've got requirement classes. Most of them are recommendations and only few are requirements. Keep in mind that if we go down to requirements, it means legislation, implementing rules. So yeah, there are a lot of should, but it's some of really worth using, I mean. So there are requirements on the observation, like an O&M observation should have an identifier, unique, so that you could go back to that observation a couple months later and still retrieve the same result. Okay, requirement on the way you should structure your time information, requirement on, basically it's going down to all the leaves Cathy presented now, revolving around what is an observation. So then requirement of observed property, really trying to enforce the fact that community should have community managed vocabularies exposed in a common manner, the way to point to feature of interest, and we even provide a pattern for depth elevation information provision. There was a lot of discussion regarding the procedure because there is an overlap here between the EF theme and this work within O&M. So basically we went to the path that saying sensor type is not an instance like this sensor, serial number XXY, but it's more this type of sensor, and also providing an entry point to dedicated process specialization in Inspire. There is a pattern to link from the observation back to the facility and or the network that generated it, and also a small requirement in the case where observations are behind, say, a URI resolver. Then the last chapter is in the 2.9 is regarding the service layer, because it's nice to have like theoretical UML kind of requirement, but people need to implement services. So of course we provide an entry point to the other document. We enforce one extension that comes from the OGC source hydro profile, that is a gate data availability. It enables you to enable a client to test the infrastructure, whether there are actual results under a given offering identifier or for a given observation or observed procedure, observed property. There is this also proposal to have an hierarchical offering capability so that you are able to expose the capacity, all that is observed in the country, for example, but without exploding the get capabilities response. And we have a recommended service pattern to link from the feature services exposing the network of the facility down to actually linking to the observation that makes sense to your use case. And yeah, we've also been working closely because some of us are like 15 hours BRGM and others are also actively working in the OGC SWE group. So we also, the hydro domain working group. So basically we also exposed, I'm skipping, this slide. This approach we had to many other groups that it's not a European, this exercise wasn't for European needs, but also taking into account feedback from other people. And we also have a last chapter identifying the other activity worth following over the next years. And a quick word about the second doc, the technical guidelines for SOS. Basically, there is the extended capabilities for metadata, the mapping of the OGC terminology to the inspired terminology, like offerings equal inspired datasets, the recommended behavior for described sensor observation, the way to handle as well what is an identifier of an observation. And I guess that's all for this overview of the two documents. Simon?
Okay. As next part, I would like to introduce the implementation we did as part of the activities together with BRGM and JRC. And this is an open source implementation of the concepts that were just introduced by Alexander Kotsev and Sylvain Grelet, where we took basically and worked with them together during the specification process to validate the ideas and to provide also to data providers something, a reusable software package they can integrate into a software infrastructure and start serving the data using these SOS functionalities. So what we included in that implementation was mainly the additional metadata, as well as multi-language, multi-CRS support. That means we are now able to serve observation data in different languages. You can specify different translations for the same terms. That's, for example, relevant for observed properties where you may have rainfall in different languages. And then, of course, we included support for a set of specialized observation types, which can be used then for different application domains where they can be, represent the data the experts are dealing with. This implementation is available as open source software, so you may have a look at GitHub. There's also on our wiki more detailed information and documentation available explaining how to install it, what are the specific features which have been implemented. So if you like, the slides should be available later on. You may have a look at these links. So what did we do with regard to the specialized observation types? We included a quite large range of different types of observations. So we had the point observation, which is basically the latest measurement or some measurement of an observed property at a location. So an example could be you are measuring the air quality at this right moment here in Barcelona, and that would be a point observation. If you are doing a continuous monitoring of such a property like air quality along a time period in Barcelona, like having a station measuring every hour, you may talk about a point time series observation. That means at one location you have a series of observations with different timestamps so that you can see how the phenomenon develops over the time. Other observation types may be multi-point observations. That would be if you have one property measured across a whole network of observation stations. Could also be air quality, like having an air quality network across of Spain. Then at each station you are measuring perhaps at the same time the same observed property. Then profile observations, measuring certain values along a depth or height, so like profiles going into the ground. And finally, trajectory observations, where you have mobile sensor platforms like research vessels or cars taking some measurements. That would be trajectory observations. So these are supported in this implementation, and you may use them for your data. Besides the pure Inspire stuff, there are also some other features I would like to point you to, because a strong focus of our implementation was to facilitate the integration into existing IT infrastructure. So we can connect this SOS implementation to different database management systems. We tested it with Oracle, Postgres, MySQL, as well as Microsoft SQL Server. And using object relational mapping, depending on your existing database structure, it may be even possible to configure the SOS to run with your existing database. However, besides this configuration part, there are also other well-tested approaches available how to integrate the SOS Some of them are in the wiki, others will be documented in the next time. For example, using database views or other strategies, how to integrate SOS with the existing data infrastructures that you are running. Then there are a couple of extensions available. So Inspire is one thing, but there may be, for example, air quality reports that have to be delivered, like the delivery of air quality measurements to the European Environment Agency. There are some countries using the SOS for fulfilling these reporting obligations for air quality and being Inspire compliant at the same time. Other things are, for example, in hydrology, we are supporting the hydrology SOS 2.0 profile together with WaterML support. So it's quite flexible that you can, on the one hand, cover Inspire requirements and then also fulfill certain domain-specific profiles. So to illustrate a bit more, I would like to switch now to the part where we have a look at different implementation examples. This is one example where we are talking about trajectory observations. This is a result of one of the European projects in the marine community, specifically the Nexus project, which is in the Oceans of Tomorrow context. And in that project, we are dealing, among other sensors, also with ferry boxes. These are sensors mounted on ships, and these are measuring continuously certain oceanographic parameters, and then using such trajectories observations, you would be able to display a track on the map and a corresponding diagram showing the different values at certain positions of the track. So that's one typical approach. Another one, I mentioned the air quality work. This is a screenshot, and the next step you will also get some kind of live demonstration if everything works. So here we are accessing a point time series observation. That means here we are connected to two observation stations for air quality, in this case in Belgium. And as you can see, we have a diagram view showing how the values change over time, so that you can use, in this case, the point time series observation as a good example. So that's with the introduction part. Now we will come to the flash presentation part, where we will see different examples of sensor web applications. And I will just continue with the air quality e-reporting work. What you can see here is a network of air quality stations in Belgium. There are several member states using the SOS. So our implementation is deployed, for example, in Belgium, Lithuania, Sweden, Netherlands, and United Kingdom. And they are using the SOS for sharing their near real-time observation data. And we have prepared a short live demonstration. So here I'm connected to an SOS running in Belgium. So we may have a look at the map. Whoops, we need to change the provider first. So we connect to the SOS from Belgium. Then we get a look at their station network. We may say that we are interested in certain observed properties. So for example, we are interested in the current ozone measurements. And then we can see which stations do we have. Let's have a look at this one. And here we have an ozone measurement, northwestern area of Brussels, from today, 10 o'clock. And we can say, okay, we are connecting to that SOS server. The data is downloaded, and then you get display of the data directly in your client application. You may even connect to other data providers. So for example, we have also, let's take this one, data from Sweden available online. Other providers, let me check, are for example also from the Netherlands, and there you can get as well through the same access mechanism in this interoperable way. We are looking for ozone data, connecting to the SOS in the Netherlands. There we have data from 11 o'clock. We are connecting again to the server in the background, and the data is downloaded, and now you get the data from different countries using the same interface in your client application. So that's a quick introduction how SOS has been applied for air quality. Then another big topic are marine observations, where we also were able to do a lot of these implementations for validating the Inspire approach. This is work we did in several European projects, so Bridges, Fix03, Nexus, and ODIP2. These are all projects in the marine sciences domain, where we are working on the one hand with stationary observatories, on the other hand with mobile sensor platforms like research vessels, but also gliders, underwater gliders, and there we are applying sensor web technology as well to share the data. And with this, I would like to hand over again to Kathy, who will talk about the Austrian work.
Okay, I'm going to give you an overview of the SOS implementation we did for Austria, which actually we should talk and see if we can't integrate our services into your viewer. That would be a nice proof of concept. Okay, anyway, this is a different approach we did. Started with the Austrian National Database. And first we said, okay, we need to get all the spatial stuff on it, so we set up a geo server for doing the feature service. That we did with a dedicated database where we ETL it all out, because the national database, it's too linked to the national requirements, and it's a mess. It's decades old. You would not want to link to this. So we did a second Oracle database, ETL'd all the data there. In that database, it's all nicely already compliant, aligned with the Inspire structure, put that on GeoServer, everything was happy. For the SOS, we then looked at this and said, okay, we weren't quite happy with the 52 North implementation, and we thought for the real-time data, we wanted really coming off of our live systems. And since we've been working closely with the Austrian Institute of Technology, which has been one of the pioneers with the sensor web technology, we decided, okay, let's see what they can do for us. And so they built a new SOS server based on their OpenUVA system. That's the extension. I mean, they built the original air quality database 20 years ago, have been developing that technology further, and when I came up to them 2 to 3 years ago and said, hey, let's extend this to SOS, they said, cool, let's do this. And the nice thing there is this is very lightweight software. It can be configured to any data source. So it has no native database of its own. You have a simple Java data handler class. There you need to fill out the code for a handful of setter methods, open and close methods, filter methods, provide a data type to basically where you can put your time series in, and it runs. So the nice thing about it is it's lightweight, it can attach to anything. But then we had the question, okay, that's nice for the data, but now we've got the real information on the feature of interest and also the process information. We have it nicely ETL to the database we're using for the feature service. We're worried that this is going to go at some point diverge, because that ETL process is done maybe once a year. If something happens in between, we have more up-to-date data on the SOS than on the feature service. And I don't like inconsistencies. And after many long nights and quite a few beers, we realized, wait, actually the response of the feature service and the response of the SOS, the only difference is the wrapper. The features provided within the response are exactly the same. And therefore, AIT implemented their OpenUVA.sos to work with a coupled feature service. And when it gets a get observation, it goes directly to the data source. If it gets get feature of interest or describe sensor, it passes this request off to the feature service, gets the response back, rewraps that as an SOS response, and provides it to the customer. Okay, and here are links which we need to at some point get linked into the portal.
Okay, continuing the example of working deployments. Feedback of what we did at BRGM for various geoscience fields. So first, and I guess I spend more time on that one, is we're exposing, according to ISO 1M and Inspire requirements, our near real-time groundwater level monitoring system. So how is that working actually? Is that basically when we are enhancing our groundwater monitoring facility called piezometers, with GPRS technology, so that the base is a push their observation at a certain rhythm on a file system. That's not really interoperable here. So we have a magnific development here, and then we move to a ONM compliant database, and then on top of that we plug a SOS, and given that we work on an ONM compliant by design database, it's quite fast to expose. And we're exposing for colleagues groundwater, but also groundwater level, temperature, and salinity as well is foreseen. What is nice is we have gathered various type of sensor types into fitting the same type of harmonized database. So that's basically the same speech I had last year. Is we're now down to one pivotal mechanism of exchange of information. That's the purpose of interoperability as well. And then we can quite fast and easily plug various reuse on top of that. So it's a screenshot from the 52 North web interface where our domain people can actually look, explore, and hopefully validate raw observation acquired on the field, because the sensor can have some bias over time, these kind of issues. The same information flow, the same source compliant to Inspire specs and recommendations is also exposed in the National Groundwater Level Observed Archive. So this is what has been validated by hydrogeologists, and what it's read is what has not been yet validated by a domain person, because each point is being validated before publication. So it gives some kind of forecast type of information. Again, the same information flow, that's why it's interesting, is used in a project called Météo-DENAP, could be translated in weather forecast for aquifers, where basically we've got this, on its own purpose, it's a black box. There are various modeling tools in hydrogeology, and we feed this kind of beast with our source flow, but also surface water information and methodology. And the idea is to have some, this exact same type of what you've got for weather forecast in the air, but underground, actually. That's really nice because a lot of reuse, and that's something also that could be interesting to reuse the QGIS GML application schema. We will present into more details on Wednesday afternoon. This is some dev we've done around QGIS in a generic fashion, not at all tailored, attached to EF or WaterML or point time series. The fact that an XML point to XXSD, so basically you could create structure out of the flow. So this is what our domain people can do now, consume the EF monitoring facility piezometers information, exposed in an Inspire EF fashion. And if you scroll down a bit down the XML flow, it could also be a database structure generated on the fly. You can also visualize that. The only aspect that is attached to the data structure, that is hard-coded, I would say, is the way to parse like a WaterML 2 time series. But at some point it makes sense how to plot the graph. So that's all for what we've done for groundwater real-time monitoring. We also deployed the same rationale for our geothermy platform we are having with our geothermy people. So basically sensors feeding a raw observation database, ONM compliant, so there is a source on top of that. And we have an entire building at BRGM being monitored thanks to various types of sensors. They are really creative there. And there you get one of the flow of this geothermy platform. That's interesting as well, because it's quite fast from an information system department to redeploy that. It's the same rationale, it's just a parameter and the observed property change and procedure, that's all. And then we're starting to explore the profile observation type as well, because there are other colleagues that basically, that's one of the big job at BRGM is to host the national borehole database. And they are structured in some national fashion that is not at all, I shouldn't say that, it's recorded. It's not interoperable really for now, and we are trying to solve that issue. So basically that's a screenshot of one borehole, and this is not per se full 100% Inspire, it's an extract from groundwater ML2. But we will merge that at some point. It's exposing another type of information, the profile one, according to a generic interoperable data format. And then what's ongoing? So we are working on exposing validated groundwater level database. We're also working on exposing groundwater quality. It includes specimens. That's really interesting from an IT point of view. So my main conclusion here is we have happy domain people because they are really happy to see their observation after many years hearing us, telling us, we can do that in an interoperable way. Now they can feed, they can work on what they're produced. So yeah, they're really happy. So it means that somehow we're on the right tracks. I guess it's your.
So, hi, I'm presenting here a few slides on behalf of a bigger group than me, mainly from two institutes of the Italian National Research Council, especially working together in an Italian flagship project that's Ritmare, Italian Research for the Sea, where we developed an open source software suite where the main goal was to enable non-expert groups of researchers, in this case, to serve both standard, let's say, normal geospatial and also observational data, and the metadata connected in an interoperable way through a network of autonomous nodes, so that they were able to collect, annotate, and deploy the data. So it's an open source software that we developed and gave to different groups that were not autonomous in collecting and deploying data, so that the total, the big network could be more interoperable than before, at least. And this geo-enabling information toolkit, I forgot to say the name, the Get It suite, supports researchers to insert various types of observations through the use of SOS standard and ONM. The use cases in Ritmare are both real-time observations from sensors and also manually recorded observation, so from platforms and also from surveys. Using the server side of the 52 North implementation, and also as a main geospatial portal technology, the GeoNode open source software. So we have Get It is building a complex environment where you have a standard web view and discovery application, and also it's showing SOS data through a standard simple client, able to show time series and plotting the data on the interface. And so we presented three main type of observation types we were using in Get It, and that can be a point with multiple results, so that, for example, physical collection of data on water temperature or hydrodynamical data, like current, direction, intensity of collecting different areas, in this case of the North Adriatic, and specimen also collected from surveys, and so collected in the field and analyzed in the laboratory. It's quite an important part of the work on our institute. And where in here, another type of a sensor, we have the photo of the sensor, Alessandro Gioni, our colleague. So our observation of species, so identification and distribution of species collected by humans, and so added as a SOS information in the portal. And you have the links to different type of, you don't have here. It's another service, so presenting in the same interface. In addition to the Get It, so and strong connection with it, it has been developed EDI, that's a metadata editor. It's configurable for different schema profiles. So it's it presents ex ante support of profiles, trying to present a user-friendly or more friendly than HTML or XML text files, so that can produce generate document on information related to sensors, and it's more easy to compile information compliant with SOS standard. And the schema profiles are supporting both Inspire ISO 19139 standard and you can see here the national Italian implementation of the Inspire schema, and the sensor ML defined by SOS lightweight profile of stationary in situ sensors. So this is an ongoing work, but already available as a demo and again as an open source software. Then I have a couple of slides a bit more technical on behalf of Paolo Tagliolato, who developed this part in the LifeWatch Italia project, and I have some notes, just not to say something bad. And it's about the LifeWatch infrastructure that's operating on the idea of a service-oriented science, so trying to leverage existing resources to favor ecological and biodiversity studies. So the focus is ecological and biodiversity. And LifeWatch is developing its virtual research environments, as they call those virtual laboratories, to enable scientists to easily access and exploit these online resources. In particular, what they call an implicit workflow of scientific activities can be formalized and executed by so-called workflows, so workflow systems. And in the case of the alien species virtual laboratory in the LifeWatch, LifeWatch Italy make use of the Taverna Workbench. So that's a software initially developed by the Migrate project and now under the Apache incubator. So it's an open source software, and trying to move this concept to ecological domain. So the strategy followed is to develop sub workflows, so small pieces of workflows that made available in this virtual laboratory as a modular component can be reused in the new workflows by other scientists or institutions. And this slide is trying to show how this workflow is applied. And SOS download service is it's an interesting example of an online resource exploitable for ecological analysis. And what LifeWatch Italy developed still a proof of concept. It's a module, as I mentioned before, one of those modules. In this case, it's a SOS client using data from SOS services of the European long-term ecological research network. So there are SOS be used by this module. And this slide is showing this example of workflow. In this case, implementing an analysis of phenological signals. In particular, it evaluates the central tendency index. It's an estimation of the peak in the growing season. And it's important for repeatability. So the repeatability of this kind of analysis is important for identifying variation in this central tendency index peak that can be a consequence of an impact of global changes. So that's the reason to have this workflow reproducible. And the SOS client module offers some interactivity for the users, especially not the user who developed the workflow, but other users, so that they can choose among the observed properties, for example, chlorophyll offered by SOS, and choose the feature of interest. For example, a specific lake that's one of the part of the long-term ecological research network. And so we have a continuous update of LTER time series sensors and the data distribution through SOS services. And this is a key component of a repeatable and also reusable analysis workflow for ecological monitoring of the environment. That's one of the issues of the LifeWatch infrastructure. And that's, okay, back to you.
So now from the marine and life watch use cases, we dive a little bit again into air quality. So what I'm going to show you is the first and only, to my knowledge, physical object. So it's a sensor that implements an Inspire download service by design. So well, it's called Air Sensor. It's a research project of the Joint Research Center and some partners. We've been working on it since 2015. And it's done in collaboration with the European Reference Laboratory for Air Pollution, which is part of the Joint Research Center. So this is the research laboratory where all the reference laboratories in Europe, each country has got at least one of those, goes to calibrate their air quality stations. So this is a group that really takes the quality of the observation data seriously. So they have been dealing with how to make the most out of low-cost sensors for a few years now. And our group was dealing with the data management of the project. The high-level objective was to create something which is an open hardware and software platform for multiple sensors, which is able to meet the requirements of the Inspire directive regarding download services and the air quality directive regarding the quality of the observation data. So what we came up with is an object that is not only interoperable in terms of and open in terms of software, but it's also open in terms of hardware. So it is licensed under something that is called European Union public license, which is very similar. It's based on Creative Commons. So it is reusable, and we have published on a wiki all the design of the hardware and pieces of software that have been developed. So this is actually called, this is an air quality shield. The arrows point on where the different sensors are to be connected. So we have 4 channels, so we can connect 4 different sensors. Interesting feature of it is that it is open by design, so different sensors from different vendors can be connected, which is very different from the usual situation where a vendor, a producer of sensors would really do everything possible to lock users into his own solution. So here there are colleagues have identified 500 plus different sensors that can be connected. So assume, for instance, from the different makers for sensors measuring one gas or for different gases. So this is the what we call the sensor shield, which is connected to a mini computer. This mini computer is called Arietta. Arietta is something very similar to Raspberry Pi. So those of you who are in the making of do-it-yourself type of hardware know Raspberry Pi. It's a mini computer which is ARM processor, and there is a Linux running on it. So this gives us a lot of advantages. We'll run Java directly, and it is connected to this sensor shield. From there, we are able to push directly, send the SOS transactions. So we have done a transactional sensor observation service. So we directly push the data on an hourly basis to an SOS server. We are using the 52 North implementation for that. So on a regular basis, from here we push to the database, and there is a sensor observation service that sits on top of that. The nice feature is that if we're measuring the same gas, it's very, very easy to mash up with the official data. Of course, we are dealing with a granularity which is a lot higher here. So we measure every 10 seconds then we can average, whereas the information that Simon showed was hourly. But in any case, we can see, we can combine those different sources of information together. Results, we have 17 million observations collected now, and we're trying to issue a series of technical reports to ensure that This can be reused both in terms of, as I mentioned, software and hardware. So I have one of the objects here. Tomorrow when we have the Inspire stand, hopefully we will have it up and running, so you're very welcome to come and see. Final thing I forgot to mention, we have also 3D printing patterns for the boxes. So there is one can reproduce absolutely everything, including the boxing. So this is basically the air sensor project. Now, this having been said, we hope that you got a flavor of the different heterogeneous use cases. So you see that the technology is mature enough, that there are different ways ahead if you want to work with your spatio-temporal observation data. Of course, being a rapidly developing field, there are some challenges, of course. So now Kathy will let us know what is the bright future and how we can handle the existing issues.
Okay, so I mean, we've come a long way considering that, when were people still telling me I was crazy trying to get SOS and Inspire? No, but it's finally, it's becoming accepted, so I think we've come a long way since, but we still have work. So, I mean, one of the open problems, which I'm not sure how we're going to sort it, but it's good if people are at least aware of this, is that there was an error made in the transposition from some of the data models to the IRs and the code lists. So within the environmental monitoring facilities, for example, if you go through there, if you look at the code lists, of the, I think, 7 code lists, 2 are extendable by users, 5 are predefined and not extendable. And then you go into the IR and they're all open. And so we managed to get sort of an in-between solution. The code lists are now in the Inspire registry. We hope everybody will try and use those. But this is one of the confusing bits. Maybe admit somewhere as a next step, we could also get this nailed down again in the IRs. We'll have to see. Further bit is the feature of interest encoding. This can become a very philosophical discussion. What is really the object I am measuring on? And I mean, we've all had great long arguments with lots of beer on this and saying, is it the measurement station? I would say no, it's not, because actually I don't want the ozone concentration of the station. I want it of wherever I'm measuring. So at least in my philosophy, it's the air bubble around the intake, the water you're pulling the water out of. It's not the measurement device. So this is also something which still needs to be nailed down a bit more and clarified. Okay, this is the really ugly part. That, okay, you've seen the various models we have for result provision, and we've got all of our different classes saying this is for a single point in time, this is trajectory, this, that, and the other. At the same time, we said, if you have your data available in a format that is normal in your domain, I mean, one example which I keep using is NetCDF. And certain domains work in this, and I am not going to tell people to take this huge block of NetCDF data and try and pack it in an XML result. It's not the right technology for it, and let's just leave things where they work. And that's where we said, okay, let's accept out-of-band results. Say if you have a result in a known standardized format other people can work with, leave it there, provide some information on what is there. That's one of the open points. Some of the other open points we also need to sort is with the very specialized observations. It's all very water-focused right now. This comes from the fact that the water people have been the most active. There's the most water activity in OGC, but somewhere in there we actually have a reference to WaterML. And I admit the air quality model, which I did several years ago before all of this was finalized, I didn't use any of it. I just stayed with the plain observation. I wouldn't want to try and sell to the air quality experts why they now need to include a part of WaterML to serve their air quality data. So these are various bits we need more clarified. is there anything else coming after this, or? Okay, so my final pitch here is we've come a long way. There's still a lot to be done. Any of you who are interested in helping us, please join the cluster, join our meetings, get involved. It's, as you've been seeing, it's the same faces which keep popping up on this stage, and we need support. And we've been trying to see when could we have a cluster meeting this week. The week is so packed, and based on people's schedules, what we'd really like to do is just meet up this evening. So the plan is, I'm not quite sure where we will be standing, but remember the faces who circled through the stage now over the last hour. We will probably coalesce somewhere at the end of the day, so around 5:30. Find us, and we will try to find a place where we can go externally, where we have some beer for inspiration and room to wave our hands, and try and sort out what's open and where it goes from here. Huh? True. Okay, so if there's the, what is our cluster called? Observations and measurements and environmental monitoring facilities and stuff like that. So there's a good chance it'll be up on the cluster once we have our beer. If you want to join us for the first beer, get to us in time. If not, check the cluster, and we will sort of leave some breadcrumbs for the people following us. Open mic. Questions?
I was wondering, say that you have your sensors in place for some time, and at some point you realize that the measurements were flawed because of malfunctioning sensor or something, and say that, to keep it simple, there was an offset applied to all measurements. So what happens? You go into the database and fix retroactively the data, or whatever you do. How do you advertise to clients that might have already read your data that they might read the same ID but get different results, or simply to document that there was this flaw in the measurements?
Okay, I'll start on this, and you all will help me. So, I mean, the first thing, I would not override it. That's bad voodoo. Leave it there, do a second version where you then have the validated corrected data. The second bit of information is that the result, I mean, at least with a time series, you always have timestamp value. And if you're sensible, you also have various verification validity information. So with the air quality data, we actually have each individual entry has 5 values, where we said we have start and end time, because we have variable length measurements. We've got the measurement value, to what level was this verified, and is it valid or not? So that's one part of the answer. The ID is a tricky bit. The ID I'm going to pass on to Sever, because he's been working on this more than I have the last months. So how's the get observation by ID going today? You take the microphone or get up here or talk your way out of this.
Yes, one of the most important points here is not overriding. I can base my answer based on what we're doing for raw groundwater observation. And each point, like I said in my presentation, is validated by a domain person. And it's promoting in a data validation status workflow. And if something is biased, something has to be corrected, it's another observation from an identifier perspective. Okay? That's core, because you want to be able to go back to the initial raw observation. Then the question is, once you get an identifier, here we don't have continuous measurement, it's like 1 every hour. So it's quite easy to say that the raw observation is 10, 11, 12, and we generate a new identifier if we have to correct the initial observation. And we've decided, initially I was thinking we could link, because in UML it's here, each observation could be related to another one, related observation in O&M. After further discussion with Simon and 52 North folks, we've decided to try and link at the series level as well. So basically, or link the offerings together, so that you can have the initial raw observation and then the corrected one. And then, because my use case, folks start from a time series perspective. And if they want to go down to one specific point within a time series, you could also do that via the identifiers as well.
I mean, a further insight from my side is very related to if you're doing some sort of higher level aggregated values. So your use case of saying, I changed it, I adjusted it, recalibrated it, is similar to saying I'm going from hourly means or the 10-second means to hourly means to daily means. Those are individual time series in their own rights, and they have to be because there's a different process. Because if you stay with the original observation, there's no information how you recalibrate it. That should be added to the recalibrated observation so that whoever's using that understands what changed. Does that answer your question? Okay. Alex? Okay, you're answering some more, very good.
No question for you, Kathy. I just wanted to also reflect on what Angelo was saying. With your question, actually opened Pandora's box easily. Uncertainty of observation data is probably as old as SWI is. So, and it's not straightforward why, for instance, sometimes the outlier can be an error, but then it might be a phenomenon. For instance, there was, in the field of air quality, there was this small tractor cutting the grass around the station, emitting a lot of pollutant, so immediately you see this value which goes up in the hourly data. You will not see this, but this doesn't mean that, that there is no something that is objectively causing this to be the case. There's no straightforward answer. There are many strategies, I think, but calibration, maybe having one endpoint for the raw data, one endpoint for the calibration data is what at least we are trying to do, because colleagues of the air quality are implementing an artificial neural network on top of the raw data, and then they're reusing the same technology, pushing, but it's just another database and another endpoint of the SOS.
Hi. So in fact, we are pushing a bit the sensor observation to use it for manually made observations. And it gets a bit worse than just correcting values, because you do have primary observations made by people when they are in a survey, which then, for example, wrongly identify a species, but it can happen. And then you have further corrections and further analysis made over that species, which lead to second-order observations, let's say. So it's really important to keep this relation between features and, well, where they came from.
Well, you're actually doing biodiversity identification via sensor web?
Yes.
Cool, we have to talk. I've been trying to find somebody stupid enough to do this for years, because I knew it's possible. I'm thrilled. I mean, I've seen that Ale is also doing some stuff in that direction. I think the three of us need to have lunch, because, and exactly what you said. I mean, what do you use as your feature of interest?
Yeah, the station has primary ones, and then we use the sample ID as secondary ones.
Okay. Because I know we
still have a location, and that, well, actually, sensor is the station is just a general identification of the location. Then we keep the actual locations of where it was fished or sampled or whatever.
Okay, very good, because the standard mistake is assuming it's this type of tree and then getting very confused when somebody comes up and says, it's something else. So
we have the actual location of the measurements, yes.
Very nice. Nobody else? No more questions? Did I scare them all? Alex, maybe you should come in and then they'll ask more questions again.
Yes, maybe we can give it a try. Who has tried implementing or using an SOS before? If you can please raise your hand. Okay, so there are a few of you, so we would look forward to discussing with the rest. Maybe we can do demos later if you're interested, and yeah, we can showcase maybe some things. So please, we encourage you to come talk to us bilaterally, and then we can open a computer and maybe we show you the use cases that were presented. We know some more, so we encourage you to do that. And if there are no other questions, let's just do like that. We will be here for a few minutes. Come talk to us in front of a computer, and we play with the actual services if you want. There's a question. Can we please just use the microphone? Because they're recording. It's for the.
I'm from the Swedish Environmental Protection Agency, and my question was, we are working to establish an inspired data flow about related to the invasive alien species directive, and I was wondering if this is a way of working with that type of data or not, and what your thoughts are about that. We are just beginning from zero, so that was my question. Thank you.
I mean, as I just stated with the last comment, to my view, it's ideal for not just for things where you've got a sensor, but you can perfectly go and say, this beastie, that's a such and such, and here we've got the giant hogweed coming in we want to get rid of. So it's ideal for that, and it should work on all levels. Where, I mean, Alessandro, you've been working with this. Have you encountered any problems with it? What?
The general one you're presenting does have problems.
Basically, keep in mind that it's just as long as you acquire or generate an observation. So simulation falls also into that. When I was speaking about boreholes, for example, some of our borehole logs are not real. They are based on mathematical 3D models. And this also an observation. It's not always acquired by a sensor. It could be a human being or generated by a computer. That's, just keep in mind, is that something is a result of an observation. That's all. So you definitely fall in.
I mean, again, starting with the observation I showed at the beginning, anytime this additional metadata on the value you're providing is relevant, it's relevant. So.
We always, a few of us have to answer every question, so let's continue with this tradition. I don't know, you have probably followed, there is a European Alien Invasive Species network, EASIN, which is a database, pan-European database, which is maintained by the Joint Research Center. So they are going in the INSPIRE direction. It has been already analyzed, and we have come up with a proposal for how to ensure that their data is INSPIRE compliant. At the same time, but it's not based on observations and measurements and SOS. They're dealing with statics, they're dealing with geometry of countries usually, or of some subnational country units, and what is the occurrence of a particular invasive species inside. Okay, at the same time, there is an open source application which is being developed by a JRC project called MyGeos, which is being used. It's a non-standardized again, but it's used to collect observation data for invasive species. Again, in accordance with this invasive species regulation. Now, this I have installed here, I can demo to you. It's again an open source project. Again, non-standardized, but if you want to be reusing some of those tools, if you want to be establishing at the Swedish EPA a national system, then it would be very, very interesting if you would like to build a layer which exposes the observation data and possibly communicating with EAC and possibly communicating with your Swedish stakeholders. That would make a very, very interesting use case, and I look forward, if you're interested, we can discuss bilaterally without knowing really your plans on where you want to go on a national level on that.
For species distribution is linked to observations.
Yes.
So that link is there. You can provide the observation. You can have your species distribution polygon and then go into the individual observation based on. I think that would work exactly that way.
So if there are no questions, thanks a lot for the attention. We hope that you enjoyed this marathon through SOS and ONM. Thanks a lot.
Marathon